introduce yourself.
Oh, thank you very much. Thanks for the chance to talk to you a little bit about the book, which I had published last year. So it's just over a year old, with the title Timber, How Wood Can Help Save the World from Climate Breakdown. And I'll just do it. So it's a bit from the book. It's a bit what's topical at the moment. And then I'll, less so with slides, but just pull out and talk a little bit through the insulation issue, which was, I guess, in setting out to write the book, I had a fairly good idea of what I wanted to say. And there was a chapter on insulation, and the insulation chapter was the surprise, because as I set about writing it and digging out the research to go with what I thought was what I was going to say, I realized I was going to have to change what I was going to write in the book, because I had got some assumptions a bit wrong. Which didn't happen with any of the other chapters in the book. So, you know, I had to do a bit of a double take. So I'll share that with you as we get on. But I suppose it makes sense to maybe start with, you know, topicality, where we are at. So we have a government which has pledged to build in its 5-year term 1.5 million homes, which is obviously a bit of a shock. I think we've got someone
Stina.
on.
Yeah, just going to turn that camera off.
So you know, different views on this, but I think most people think it's a pretty ambitious target. But it, you know, what is blatantly obvious is the government have a big house building target, and that presents both an opportunity and also a threat from a climate point of view. So we've got Green Alliance, where the umbrella group for the green NGOs, pointing out that if we are going to build a very large number of houses, this may have a big impact on our carbon budget, because if we build 1.5 million houses, future houses, in the way we built the last 1.5 million houses, with a very high level of carbon emissions associated with them, then we just can't reach our carbon budget. And there's a worry that the politicians haven't got their heads around the fact that building houses does have a threat within it, as well as an opportunity to create the new homes that we need. We were at the Labour Party conference the other week, and I think it's fair to say that our fears were not really mitigated from the conversations we had. We had a fringe meeting, which we did along with the Labour Housing Group, and there does seem to be a disconnect at the heart of government in relation to the climate impact of building a large number of homes. And we're obviously making an argument from the point of view of the Confederation of Timber Industries, but it was very much the argument of the book, which is that by switching to nature-based materials more as and where appropriate in construction, and timber being the leading material that we have the most experience with, there's these 3 big opportunities in relation to the climate. So there's the sequestration that the trees do in the forest. There's, you know, a chapter in the book about European forestry, where the timber comes from, etc. I think people will be aware that we import 80% of our timber, Sweden being the biggest single supplier. We grow very little of our own, but where the trees are growing, the carbon is being sequestered from the atmosphere, and that's sort of step 1 down the road of benefit in relation to climate. And then 2 big benefits come out. There's a substitution effect when you use wood instead of brick and block or concrete or steel. And there's also a storage opportunity in that the materials that we're using can store carbon. And I think it's here that you can see the insulation issue in the substitution and the storage. So a decision about using this insulation or another insulation is a decision, and it could well be that you can substitute out a material which has a high level of embodied carbon and replace it with a material that has a lower level of embodied carbon. And sort of in the chapter in the book where we looked at insulation materials, it's polyurethane that comes out kind of like, you know, top of the list for having a very high level of embodied carbon, primarily because it's an oil-based material. So not surprisingly, it has a high level of embodied carbon. And then, you know, the list drops down. And if you were to use, you know, the common material, sort of stone wool, mineral wool, it does also have a pretty high level of embodied carbon, because you're melting rock at 1,500 degrees. And to reach that temperature, in most cases, you're burning a fossil fuel, and therefore high level of embodied carbon. Having said that, there are some individual operations making rock wool now that are using green energy, and that immediately impacts on the figures. So there's somewhere in Switzerland where I think they're using hydroelectricity to generate the heat to make the rock wool. And the same company is making the same material in France. So from the customer's point of view, it looks the same, it's in the same packaging, everything about it is the same, apart from it's from a different site where it was manufactured. And as a result, one of them has a considerably lower level of embodied carbon than the other one, and yet it's the same material. So this is where I began to realize that I needed to kind of rethink a bit on this chapter. And my presumption that a wood fiber insulation, of which we use relatively little in Europe, France is about 11%, Germany 8%, Poland about 8% of insulation, UK less than 1%, negligible amount of wood fiber insulation. Companies like Styco making it, you know, individual purchasers, no big house builders are using it. And the presumption there is, oh, well, it's a nature-based material, it must have a lower level of embodied carbon. Well, it may well have, but it might not have. And then you have to look at the process. Often it's a wet process. So the wood fiber in the manufacturing process is at one point wetted, and therefore has to be dried. So then the key question becomes, where did the energy come from to dry the insulation? And if it's come from a fossil fuel source, then up goes the embodied carbon. But if it came from a green source, which might be the waste streams from the wood manufacturing process in the sawmill being burnt, then the embodied carbon drops. So you need to look at where did the energy come from to make this insulation. And that was something I hadn't really realized. And while it's patently obvious that if you're going to melt rock at 1,500 degrees to create rock wool by melting it, spinning the liquid a bit like you do candy floss and then cooling it, that's going to take a lot of energy. And it does, but for a relatively short period of time while you melt the rock. And drying a wood fiber insulation doesn't need anywhere near the same amount of temperature, high temperature, but it does take a long time. So over the length of time to dry the rock wool, it might be that you're still using a considerable amount of energy. So it was a case of having to get people to think sort of twice, and myself included, about this process. Mm-hmm. And in addition to that, then it could be that you're into, well, what you're into is carbon payback periods. So how long did it take as a result of using the insulation, the house uses less energy, and what's the payback period in which you save the same amount of energy as you used to make the insulation material? And even with the worst materials, the polyurethane, you know, within 3 years, you've recovered the equivalent on the energy use. And a wood fiber, you might be 6 months, a year, 18 months. So there is a difference. And to building an individual house, if the house lasts 75 years, you could argue it's negligible. You know, it's 18 months difference. It's neither here nor there. Yeah. But if you're building 1.5 million homes, then the maths of it means, well, actually, it does make quite a considerable difference. So this business of the material you use, the substitution effect, applies to the insulation materials as well as whether you're using a wooden stud wall or a stone clad, more, wall made with breeze blocks. But the win-win with the nature-based insulations, as there is with using nature-based structural materials as well, is the ability to store the carbon. And none of the fossil fuel-based materials, even the best ones at insulation, don't have the ability to store carbon. So even if you end up in a situation where you say, look, this wood fiber, as it happens, because it's been produced in a way where a certain amount of electricity is used, which is not, it's just sourced from fossil fuel. And we've got a rock wool here where they're using green energy. And actually it turns out that their carbon footprints, their embodied carbon is basically the same. They're still a win for the wood fiber insulation because it can store carbon and the rock wool can't. So getting people to think through the substitution and the storage in relation to insulation, as well as the other materials, I think is really quite important. And as regards the government, just, we're fairly certain that Mary Craig, who is the Minister for Nature and has responsibility for forestry in the UK, from our various encounters with her as representatives of the timber industry, she gets it. She understands. We're not so sure about Matthew Pennycook, who is the lead housing minister. Here he is on a visit just recently to a modular homes factory, which is using steel for the frames. Could be using timber, but they're using steel. We're not sure that Matthew gets it. And part of our job is to try and get that message through. The government did produce the timber in the construction roadmap back in February of this year. Now, this began life under the previous government, so we're not entirely sure of the level of ownership under the Labour government from the previous Conservative government. But nonetheless, it was published. Mary Craig, as the minister, launched it, and it does have the government stamp of approval for an increased use of timber in construction, and within that, an increased use of homegrown timber in construction. So that's a pretty piece of good news. And this is what Mary Craig says in the introduction, which is, I'm sure maybe written for her by a civil servant, but it's got her name on it. And we're fairly certain that from the conversations we've had, she gets it, that using wood in construction is one way of driving down carbon emissions. We've lost Angela Rayner, and it remains to be seen with Steve Reed coming in whether there's any particular change. But it was nice to see this in the Telegraph at the time of the launch of the document. And Mary Craig did open the largest, newest timber office building in London, which is the Paradise Build, which is next to the main line coming into Waterloo in Vauxhall. And she launched that. I think it was sort of early summer, and you can see the CLT beams behind her there at the launch meeting. And Baroness Taylor, who is in the House of Lords and part of the housing team, she has subsequently visited. So we have a minister in the Lords from the housing team who has certainly been introduced to some of these key issues. So our kind of view as regards the government at the moment is it's a bit of a half full, half empty situation, certainly plenty to go at. Just a reminder, I'm sure everyone on the call, so to speak, and listening is aware that concrete is responsible at a global level for 8% of global carbon emissions. It's a staggering figure. It's greater than the emissions of the whole of the European Union annually, which is 7.8% or something. So concrete is and remains a major issue, and would refer people back to this article that was in The Guardian in 2019 for a really good sort of, this is just how bad it is, encapsulation of the story. That said, a building like the Paradise Building, beautiful timber building that it has concrete foundations. Those foundations are smaller than they would have been if the building had all been built from concrete and steel, because the timber is lighter, so the foundations don't need to be quite so big. But there is a place still in the palette of materials that we're going to be using, whether it's for bigger buildings or smaller buildings, for concrete. And we don't have a problem really with hybrid buildings as well. So just to recap, the substitution is a big part of what we're pushing and what was pushed in the book. This is a document which the Irish government have published recently. It was an external commissioned report, but it's now up on the Irish government's website. So they're certainly thinking about it. And in the UK, people may be aware there's a Campaign Z, or to get the building regulations changed so that when you set about designing a building and putting in for planning permission, you should have to, by law, work out how much embodied carbon is going to be in the build. At the first stage 1 would be there wouldn't be any limit. We wouldn't be saying you can't have above a certain level, but obviously this paves the way for that then being what happens in future. So to begin with, you have to work it out in advance. You have to submit it as part of the planning process. Doesn't matter how big it is, it wouldn't necessarily make a difference. Although hopefully people would say, does it really need to be this big? And then over time, it gives the government the opportunity to start to tighten it up and say, yes, from this, from 5 years on, you're not going to be able to build above a certain level of embodied carbon per square meter of the build. And that's how the process would work. And the government are thinking about it. This was a piece of external research commissioned by the British government, which is now up on their website. So this is the direction of travel. The argument would be from a climate point of view, it's just simply too slow and should have already happened. But tomorrow would be better than not at all. I spoke, one of the chapters in the book was to get across to people that we do have these structural materials now. And I still think that people are surprised by this, that we have structural timber materials which have the same strength as concrete and steel. People do a kind of double take still when you say that. And you need to point out, yep, that's true. And as a result, you can build an exceedingly tall building. This is the tallest timber building in the world at the moment, at 24 stories in Norway. Just as an aside, because as we know, often people ask about timber and fire. In the middle of this building, across 2 floors, are the offices of Norway's largest insurance company. And here's an example of what I think we'll probably start to see more of. This is in the States, in Milwaukee. This is a hybrid building. So the lower third, if you look closely, is concrete and steel, and the upper 2/3 are engineered timber or mass timber. The lower third is a car park. There's been a US building. And I think if we're more accurate in what we're trying to push from the point of view of the Confederation of Timber Industries, it's more timber in more buildings rather than more timber buildings. Obviously a kind of subtle difference there. And one of the big advantages of using timber, as I mentioned earlier, is that it's a lighter material. So you're seeing it used in these kind of difficult contexts. This is in France, where a large timber building's been built straddling 6 lanes of traffic, which you couldn't have done. You could have done it with maybe 1 or 2 floors, but nowhere near as big if you'd used concrete and steel. And this is interesting point is there where people may be aware that more than 90% of family homes that are built in Scotland are timber frame. More than 90% of them, 92%, I think is the latest figure, of family homes built in Scotland have a timber frame. You wouldn't know it because if you go to Scotland, it's all been encapsulated. You go into one of these houses, plasterboard over the walls, no sign of any timber. And on the outside, it's got a brick or some other form of rendering, so the timber disappears. So even people who live in timber framed houses in Scotland don't know they're in a timber framed house. And if you visited and went down the street, you wouldn't know. And then you cross the border into England and it flips completely the other way. We're building very little timber frame in England at the moment, and it's 80% plus brick and block. However, it's changing. And this 1-line sentence here is correct. All the UK's biggest house builders have or are acquiring or are building their own timber frame operation. I received an invitation, email invitation earlier this week, Monday, to the opening of Bellway's new factory in Mansfield to make timber frame for England. They already do timber frame in Scotland, but they're now opening a brand new factory in February of next year, quite highly automated. And as I say, all the big houses are heading that way, primarily because it's faster, and as a result of it being faster, it makes them more, it becomes cheaper, so they can sell the houses more quickly. They also would argue that they're getting a higher level of accuracy as well in the construction. So I think we can see the indications that England is now following Scotland on the timber frame, and the timber frame capacity at the moment for timber frame homes is about 40,000 a year across the UK. And the industry is of a view that it could hit 100,000 relatively quickly. So more than doubling.
Sorry, Paul, I was just going to ask, just on picking up on Bellway, if Bellway are already operating, building timber homes in Scotland, why haven't they been doing it in England then?
Yeah, it's a really good question. And you get a slight variety of answers, but it seems to come back to we build the houses the way we build them in the geography we're in, because that's the way we've always built the houses in this geography.
No more than that.
It's kind of as simple as that. And England, from what it was about 1500, we basically chopped down all our trees as the precursor to the kind of industrial revolution. We needed it for building, we needed it for making charcoal, and then coal came along, so we had a replacement. But by then, all the trees had been chopped down in England. Whereas in Scotland, this is a gross generalization, the Scots had held on to more forestry. And Scotland had continued to build with timber. And after the First and Second World War, when we realized we really had a shockingly low forest cover, and we just had to import the timber for our pit props, etc. We started to plant more, and slowly it's come back up, but it's still amongst the lowest forest cover in Europe at around, very low. Scotland's higher, England's lower for certainly commercial forestry for the softwood. So that's what it's linked to for historic reasons. But now there's an incentive to switch to timber frame. And I think the other thing is the big house builders know that the regulations are heading towards us having to build with a lower carbon footprint. So there's a certain amount of competition to get ahead of the game. And also, as well as the structure, people should figure, there's a lot of wood in wood panels. So they're not structural as such, but it adds to the wood component in the building. And then just a few words about carbon storage. I think people do realize that nature-based products like timber in the built environment store carbon, then that's a good thing. My belief is that there's a lack of understanding as to how big this carbon storage potential is. So people say, oh yeah, you can store carbon, that's a good thing. There was this piece of research led by the architects DRMM earlier this year, and they looked at carbon storage as well as the health benefits of timber buildings. And they, for the first time, they looked at 6 examples of mass timber builds in the UK. And one of the things they did was how much carbon is in each of them. And they came up with a figure which is just over 1,000 tons of stored carbon in, there's a school, there's a railway station, there's some accommodation, there's a mosque. There was a mix of buildings, and with quite a variety of amounts of carbon, but it averaged 1,000. And that was a figure which we've been able to use to start to make some calculations around how much carbon could we potentially store. And just to make a comparison about the sheer size of it. So people may remember that the Labour government have committed to industrial carbon capture and storage under the North Sea and the Irish Sea. And they will be able to capture, when it's all up and running in a few years' time, 8.5 million tons of carbon a year. So that's, it's a big figure at the cost of £8 billion of private investment, plus government money as well. So taxpayers' money is going to go into this. So just kind of hold on to the 8.5 million tons a year figure. And then look at the built environment. And if we just take homes and bigger buildings, so the carbon potential, storage potential is, it's in the frame, it's in the insulation. If you would use a wood fiber insulation, that could be hemp. And then we've got mass timber buildings, these bigger buildings, they store carbon, and they too could use a nature-based insulation. So we started to crunch some figures. One of the major house builders, who everyone's heard of, but they don't want to actually put their name to this at the moment for some reason. I'm not quite sure why, because it's a good news story, is their timber frame for their family house averages a storage capacity of 4.6 tons of carbon. And then Styco willing to go public and say, well, if you gave us that house and gave us the task of insulating it with wood fiber insulation, that would be another 3.5 tons. So you've got, in a family home built with a timber frame using a wood fiber insulation, you've got just over 8 tons of stored carbon. And then you take the mass timber and the figure from the DRMM report, that gives you 1,000 tons. And at this point in time, we have very little information about any mass timber building anywhere in the world being insulated with a nature-based insulation. They're all using fossil fuel-based insulations. So even these big, wonderful timber buildings that are going up in places like Oslo, Helsinki, are using rock wool in the main.
And is that what Paradise used as well then? Do you know?
Yes, yeah, it's not a nature-based insulation.
And
However,
what was the reason for that then?
well, I mean, this is kind of it's the same. It's because we when we built our first timber buildings, we didn't do it, and now we've built our 10th. We're still not doing it. We've just got into this way of working. And I think there has been some issues around, from a fire point of view. So I think they can be addressed, but obviously that is part of it. And it's partly wood fiber insulation can do exactly the same job and per square meter and deliver the same energy savings, but often it'll have to be thicker. So it takes up a bit more space. So that then becomes an issue. So I think it's going to change, and we now have a company called Volchem in Sweden. They're in Stockholm. Their next big timber build, and they've done quite a few now, will have hemp as an insulation rather than wood fiber. They looked at both. They went for hemp, and it stores an equivalent amount of carbon. And the ratio is much lower. It's to do with the maths of the building, etc. So you get an extra in this case, there'll be an extra 17% carbon stored, unlike the 76% on the family home.
So I know, obviously, as a Confederation of Timber Industries, you still champion, the straw insulation guys, the hemp guys. I mean, but how does that work? I mean, it goes back to a bit like having the goal, having more timber in more buildings. I suppose it's having more natural insulation in more buildings too, regardless of whether it's hemp or wood insulation.
And that's right. And I think it's a case of a kind of rising tide lifts all the boats.
Yeah.
It's beneficial basically all around. And then we took these figures and we just we started to drop them in, and just from a time point of view, I'll just go through to if you like the column where it's headed a very big increase to the market. And so if 50% of the 300,000 homes we were going to intend to build a year had timber frames, that'd be 150,000. that would give you this 690,000 tons of stored carbon. If 20% of those had a wood fiber insulation, you'd get another 210,000. Now, obviously, people have different views on the figures, so it might be less than 50%, but more than 20% on the insulation. And then mass timber bills, the calculation was our 300, our cities and our largest towns in a group of 300. And if they each built, in this case, 20-year mass timber buildings, that's where you get the big delivery, say over 6 million tons of stored carbon there. And if they in turn had a nature-based insulation, that would be another 1 million tons. And at that point, you hit the 8.1 million, which is the equivalent of the carbon capture and storage under the North Sea. So it was just to kind of convey to people that it does, using more timber and wood fiber and other nature-based materials in the built environment can be a very, very significant carbon store in keeping with industrial carbon capture and storage. So it's not a small extra on top of the substitution. It's up there. And there was this report from Wood Knowledge Wales recently, basically pushing that message home. Timber in the built environment is a greenhouse gas removal mechanism and should be recognized as such. And then there's this issue which has sort of been lurking around for a while now, but is coming back up the agenda, partly because Grown in Britain are exploring an accreditation scheme for timber products in the built environment to potentially generate carbon credits. There's potentially a lot of carbon credits which could be sold off the back of timber in the built environment. It's only happened once in the world so far at the University of Washington 2 years ago, a new mass timber building called the Founders Building. They worked out how much timber was in it, which was 1,000 tons. And they monetized it and they sold carbon credits for $150 for each ton of stored carbon. And they were bought by benefactors of the university who then gifted the credits back to the university, who then used them to offset the carbon footprint of the university for that year. It's the only time it's happened, but the sense is at a European level, certainly, that this is something like this is coming. They have a carbon removal certification framework, which is fairly advanced in its development at an EU level. And as I say, Grown in Britain are exploring something similar in the sense of a scheme which would fit within the EU framework for measuring stored carbon. So as well as building buildings like these with wood, we're also potentially generating another product for sale, which is the carbon credits. So I'll end there.